This is the video for the first test review, questions 16, 17, 18, 19, and 20. So the first question, number 16, they want us to solve this division problem with the imaginary numbers. So what we would do for that is we would multiply top and bottom by the conjugate of the bottom. The conjugate is the same two terms with a different sign in the middle. So 6 plus 3i over 6 plus 3i. So I'm going to multiply these two binomials on top and then these two on bottom using the FOIL method. So the FOIL method is first, negative 2 times 6 is negative 12. Outer, negative 2 times 3i is minus 6i. Inner, negative 2i times 6 is negative 12i. And last, negative 2i times 3i is negative 6i squared. And then I would do the same on the bottom. So 6 times 6 is 36. 6 times 3i is 18i. Negative 3i times 6 is minus 18i. And negative 3i times positive 3i is minus 9i squared. So at that point, I would attempt to put any like terms together. So here I have a negative 6i and a negative 12i. So I can write it as minus 18i minus 6i squared over this 18i minus 18i goes away. So I get 36 minus 9i squared. But remember that I squared is the same as negative 1. So that makes this negative 12 minus 18i plus 6 over 36 plus 9. So my final answer, I can combine the 6 and the negative 12 to get negative 6 minus 18i over 45. Just keep in mind that when they want you to write your answer for imaginary numbers, they want you to put the real part first. So I'm going to have negative 6 over 45 and then the imaginary part. So minus 18 over 45i. Now these guys can simplify. So 3 goes into 6 twice, 3 goes into 45 15 times. And then here, 9 goes into 18 2 times, 9 goes into 45 5 times. Remember, you have to have the real part first, and then the imaginary part second. All right, let's look at the next question, number 17. And it's a story problem. It says the length of the longer leg of a right triangle is 22 feet more than 6 times the length of the shorter leg. The length of the hypotenuse is 23 feet more than 6 times the length of the shorter leg. So notice in both cases, they reference the clues relative to the shorter leg. So find the sides of the triangle. So this is a right triangle. And so let's start back. The length of the longer leg, so they're not talking about the hypotenuse, they're talking about the longer of the two legs. So this length of the longer leg is 22 feet more than 6 times the length of the shorter leg. So 6 times the short leg, we'll call the short leg x. 6 times the short leg plus 22 is how long the longer leg is. And then the length of the hypotenuse up here is 23 feet more than 6 times the length of the shorter leg. So 6 times the short leg plus 23 is the hypotenuse. So the short leg we labeled x. Because it's a right triangle, we can use Pythagorean theorem. So we're going to go this squared plus this squared equals that squared. So x squared plus 6x plus 22 squared equals 6x plus 23 squared. So you can see where this becomes a big algebra problem. So x squared plus, I would have to write this out and FOIL it. Okay, make make sure you guys can still see that. All right, let me move over just a little. Okay. So the foiling is pretty lengthy. So 6x times 6x is 36x squared. 6 times 22 is 132. So I've got plus 132x, and then 22 times 6 is also 132x. 22 times 22 is 484. So I foiled those two to get all of that. And then here I'm going to go 6 times 6 is 36x squared. 6 times 23 is 138x. 6 times 23 again is 138x. And then 23 times 23 is 529. I wrote it down there because I think I'm at the end of the board. Okay, so let's combine like terms on this side. Well, you can kind of do it a couple different ways. You could go ahead and subtract the 36x squared from both sides. That actually would be a little bit easier. And then let's clean this up a little. So we have x squared, 132 plus 132 is 264x plus 484 equals, what's over here? 138 plus 138 is 276 x plus 529. Okay, so we're getting a little bit closer to being able to either factor or use the quadratic formula. So we want everything on one side of the equal sign with a 0 on the other side. So let me subtract 276x. So this would be x squared minus 12x. And then let me subtract 529. So 529 minus 484 would be minus 45. Okay, and now it's at a point where I can factor it. So I'm trying to think of factors of 45 whose difference is 12. So 15 and 3 would work. And if this part is difficult for you, you're welcome to send me an email and we can have a Zoom lecture where I can kind of show you how to do that factoring. But you also, at any point, could use your quadratic formula to figure this answer out. So if I set each of these equal to 0, I either get x equals 15 or x equals -3. However, remember, x is the distance of the shorter side. So I can't have a negative representing my distance. So in this case, my short side is 15. So if my short side is 15, then my longer side would be 6x plus 22. So 15 times 6 is 90 plus 22 is 112. And then my hypotenuse would be 6x plus 23, so that should be 113. So all I did then was plug the 15 into here and here to get each side of my triangle. And that's a pretty long problem. It's pretty difficult, and there's a lot of room for error. So if I was taking that on a test, I would save it till the end if I could, so that you kind of get through everything else first. Okay, so let's move on to question number 18, which is completing the square. This question is very easy, very quick. I would definitely get it done right away and then move on to the other questions if it lets you bounce around like that. So completing the square is nothing more than making this trinomial in such a way that it would be able to be factored perfectly. So the way you do that is you take the b is always the coefficient of the variable that's not squared, so just the linear variable. So in this case, b is 10. And what you're going to do is you're going to do half of b, so half of b would be 5, and then you're going to square that, so 5 squared is 25. So this may be a little confusing how I wrote the notation of it, but basically you take the 10, cut it in half, and then square that, so this would be a 25. And that's it for that question. All right, question number 19, which I think you can see. Yeah, so question number 19, they want us to solve this, and this is a quadratic. I would not try to factor it. I would use my quadratic formula. And let's see, identify A, which is 3, B is negative 8, C is negative 1. So remember the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b would be a negative 8, which will be a positive 8. This is negative 8 squared minus 4 times a is 3, c is negative 1, all over 2 times 3. Incidentally, if you type it into your calculator with the parentheses in the right positions, it will solve it for you. It'll do a great job. You may want to put an extra set of parentheses around the numerator so that it divides in the appropriate place. I would try it a few times, and if you feel comfortable with it, then I'd certainly use it on the test. Actually, I misspoke. I think you can only use the calculator that's in ALEKS for that, so I'm not sure it would do it for you. Okay, so this becomes 8 plus or minus. Negative 8 times negative 8 is a positive 64. A negative times a negative is a plus. 4 times 3 is 12. So this is all 64 plus 12. 2 times 3 is 6. So I get 8 plus or minus the square root of 76 over 6. And this is where it gets a little tricky with this 76, because this can be simplified, but if you put it in your calculator, it's just going to give you a decimal, and that's not actually what you want, because they don't want your answer as a decimal. So one way you could do that is you can take the 76 and do a factor tree. So 2 goes into that 38 times, 2 goes into that 19 times. So this is the factorization of 76, and prime factors 2 times 2 times 19. And that makes it a little easier, because if I have a 2 times 2 in there, that means I can rewrite this as 4 times 19. Why is that helpful? Because the square root of 4 will come out, right? The other thing you can do is anywhere you see a pair of 2's or a pair of something, then you pull that something outside of the square root. So this becomes 8 plus or minus 2, because square root of 4 is 2. I'm leaving the 19 in, and I still have a 6 down below. Now, when we simplify this, we can only simplify the numbers that are outside of the square root, and all 3 of those numbers have to have a common factor in order to reduce, which these do. 2 goes into 8, 2 goes into 2, 2 goes into 6. So my final answer would be 4 plus or minus the square root of 19. 8 becomes 4, 2 becomes a 1, which I don't need to write, and that's all over 3. And that would be the final answer that they're looking for. You should have a plus or minus button when you type that in, or you could type it in as 2 separate answers. 4 plus the square root of 19 over 3, comma, 4 minus the square root of 19 over 3. Okay, so let's look at this last problem, number 20. All right, a ball is thrown from an initial height of 2 feet with an initial velocity of 23 feet per second. The ball's height in feet after t seconds is given by this equation. Find all values of t, so I'm solving for t, for which the ball's height, h, is 10 feet. So what I'm going to do is replace h with 10. So 10 equals 2 plus 23t minus 16t squared. So this is a quadratic equation, and I'm going to use my quadratic formula. I like to have my squared term be positive, so I'm actually going to put these three terms on that side and move the 10 over. You don't have to do that, but I think it's easier to put it into the quadratic formula if you make that squared term positive. So basically I moved this over here, making it positive, moved this over, made it negative, this made it negative, and that made it negative. So then what? Well, I need to add the 10 in order to make this side 0. So I get 16t squared minus 23t plus 8 equals 0. Now in this question, they tell you that you can round this as a decimal. So you don't have to go as far as that other question was. You can plug it into the calculator once you get to a certain point. So in this case, my A is 16, my B is negative 23, my C is 8. So I'm going to go t equals negative 23 plus or minus the square root of negative 23 squared minus 4 times 16 times 8 all over 2 times 16. So I'll clean this up a little. The rest becomes a calculator problem. 23 squared is 529 minus 4 times 16 times 8 is 512 all over 32. 23 plus or minus the square root is 17 all over 32. So in my calculator I would do 23 plus the square root of 17 and then divide that answer by 32. And I round it to 2 places, I would get 0.85. And then I would go back and do 23 minus the square root of 17 and then divide that answer by 32 to get 0.59. So those are the 2 answers. In other words, at 0.85 seconds, that ball is 10 feet high, and also at 0.59 seconds. And the reason is because this is a problem. So at 0.59 seconds, it reaches 10 feet high, and then it starts to come back down. And here, it's also 10 feet high at 0.85 seconds. So that's the meaning of that. All right, I'll see you in the next video.